Okay, so this will actually be the third video for canceling repeated values. It's going to be similar to the last two, but in step 3 we're going to add a little bit of a complication. So in 3 we've always been multiplying the bottom equation by 10 for the top equation. But now we're going to multiply the bottom equation by 10, 100, 1000, or even possibly a bigger number for the top equation. And this is going to be so that the repeated values line up. And I'll explain what that means during this video. So let's look at an actual example like we have in the other videos. So consider we have 3.12 repeating. So this goes like 3.1212 forever and ever. If we want to deal with this problem, we're going to start out the same way we always have. So let's set up our two algebra equations, and we're going to say that we have our top equation and our bottom equation, and that's taken care of. Next, we're going to multiply the value by 110 or 100 for the bottom equation so that the decimal point is next to the repeated value. Well, our repeated values, 1 and 2, are actually already right next to the decimal point. So in this case, I'm just going to multiply by 1. And so we're going to say 1 times x is 3.12 repeated. And the reason I didn't multiply by 10 like we did in the last video is because 1 was already next to here, right? So this is taken care of. Now, third step. This is where things are a little bit new. Previously, we always multiplied by 10. But let's look at what happens if I multiply by 10 here. So let's say I say multiply by 10, I'll get 10x, that's fine. And then if I multiply this by 10, I'm moving my place value once, and so I end up with 31.2121. And if I do this, this actually doesn't cancel out. 2, 1, and 1, 2 don't cancel out. And so this is a little bit of an issue. And so what I want to do this time, instead of multiplying by 10, I want to actually multiply by 100. And so let's look at what happens if I multiply by 100. If I multiply by 100, well, 1 times 100 is 100. And this value right here ends up being 312.12 repeating. The reason this is useful is because my decimal places, 0.12 and 0.12, will actually cancel out now, and that's exactly what I wanted. Otherwise, you end up remaining in a repeating situation, which is not what we want in this case. So in this time, we multiplied by 100. Great. Next, we are going to subtract the algebra side of the equation. So I have 100x minus 1x, and that's going to give me 100 minus 1 is 99. X stays the same, equals, and then I have 312.12 repeating minus 3.12 repeating. My 0.12's repeating ends up being 0.00, which is exactly what I wanted. And 312 minus 3 is actually going to give me 309. Cleaning this up just a little bit, 99x equals 309. And that is everything for this example. So this is a very complex example. There's actually only one more step we need to do to get fractions later on, but I'll leave that for right now, actually. We'll do that right now. So after step 5, step 6 is going to be divide the decimal side of the equation by the value on the algebra side of the equation. And so when we do that, so I've done these other steps, but the very last step that we haven't done so far is I'm actually going to take my decimal side, 309, and I'm going to divide this by my algebra side, which is going to be 99. And so I'm going to say that x equals 309 over 99. And that's going to be my new final answer. Okay, So there's a lot of new stuff in that one example, so let's do another one and get a kind of a better look at what's going on. Okay, so our next example, and I'm just going to scroll this down so we can see everything. Our next example is going to be 4.075, and the 75 is going to repeat. So if I want to do this value, the first thing is I have to set up my algebra equations. So I'm going to say top equation, bottom equation, equals. Great. Next, I need to determine, am I going to multiply by 1, 10, or 100 so that the decimal point is next to the repeated value? Well, my repeated value starts at 7, and so it's actually not next to this. I want to end up with something like this, where my repeated value is right after my decimal point. And so in order to do that, I need to move everything over 1 decimal point. And so that's the equivalent of multiplying by 10. And so I end up with 40.75 repeating. So we're going to say 10x equals 40.75 repeating. Okay, so we have done this, and we multiplied by 10 in this case. Next, we're going to multiply the bottom equation by 10, 100, or 1,000 so that the repeated values line up. So if I want these values to line up, if I multiply by 10, if I just move the value over once, it's not going to line up. I need to move the value over twice so it does line up. And so if I move the value over twice, I end up with 4075.75 repeated. And the reason I moved everything over twice this time is because I want these 75s to line up. So moving everything over twice is actually associated with multiplying by 100. So I'm going to do 10 times 100 because I did 40 times 100 gave me 4,075. 10 times 100 is actually going to give me 1000x. And that is the end of step 3. That's kind of the hard part of the equation. If you can get through steps 2 and 3 especially, then steps 4, 5, and 6 should not be too much of a problem. So we'll subtract the algebra side. 1000 minus 10 is actually 990. And you can do this by canceling things out, or you could even just use the calculator. 1000 minus 10, and that gives you 990. So just keep in mind, sometimes when I do these calculations and don't kind of explain them too well, you might want to do that on your calculator, or just pause the video and kind of take your time to do it. Okay, over here I have to do 4075.75 repeating minus 40.75 repeating. My 0.75's repeatings cancel out and I get 0.0, which is exactly what I want, or 0.00. And then I have 75 minus 40, well that's going to be 35. And so I end up with 4,035 equals 990x. So I subtracted both sides. The final side that's new is we're going to divide the decimal side, so this side over here, by the value on the algebra side. And so I'm going to say this is going to be 4,035, and I don't need to write 0.00 anymore. And I'm going to divide it by this value over here, 990. And then I'm just going to leave x as this over here. And what's really cool now that you can actually see is if we do 4,035 divided by 990, that gives us 4.75 repeating, which is actually our original value. So this thing is exactly the same as what we started with up here, but what's cool about this is there's no repeating decimal places, right? So that's kind of nice. All right. This video is starting to get a little bit longer, so I'm going to stop it here for now.